We're going to talk about JavaScript, a little bit of machine learning. I'm going to highlight a little bit because I want to focus of the process and what you need to learn as an individual and as a machine to learn, and how JavaScript have evolved from the first step and until now, and anything that we can do with JavaScript. With no further ado, well, let's talk about the beginning. But before that, the expectations of this talk. What is and what is not this talk? I would like to clarify that you are not in front of an expert of machine learning. I'm not a data scientist. I'm not a mathematician. I'm not in the machine learning area, but I'm a passion. My passion is this. So the objective is to land this machine learn of this concept of all and every one of us can understand. So we are not afraid with this topic. So we can start talking about this issue, and this is not like overwhelming. So this is not an expert, as I said, a scientific mathematician. It's not a session where we are going to create or design our own learning models. But I hope that with this talk, we can learn a little bit of a basic concept, the first things of JavaScript in this area, and to play a little bit with this topic to understand what JavaScript has advanced, basic concept, and simple notions. Play a little bit with machine learning with JavaScript. And it's a talk that is something that loves this topic, dedicates a little time at night, and I try to learn about this area and to share this knowledge with you. So that's it. These are like the agenda. So something that is like very that is frightening, and is along with the history of JavaScript with this 25 years more or less. So if we want to understand something, we need to know where it start. So as some cartoons, I would like to quote this character. We start from the origin. So our and starts with the origin. So JavaScript is like that. Since the beginning, the origins, when Netscape was cool, more than one of you don't know what Netscape is. Internet Explorer was emerging in those times. I'm talking about 1995 or 96, where the web development was, well, you know, is another story. So JavaScript started there, the origins, the first stages, but currently or nowadays is everywhere. JavaScript is now everywhere. Wherever you turn around is there. So if we're talking web development, mobile apps, desktop apps, so maybe many of you don't know that you are using these apps, and for sure is as criticized as the other days, but they don't know that they are using in the communication, for example, in Slack or development, those tools that are in JavaScript. So we are using it on a daily basis. So it's part of our job. Talking about the server, this is a boom in the last years through IOGS. Why don't you think that GS is in this area, IoT, in the Internet of Things? So JavaScript is here. That small library or language that started with script language or small validation forms, or little by little was gaining land and burning or buried Flash, comparing what is today, well, it's not there anymore. And JavaScript has dominated or continued dominating. So this is the evolving. So right now we are using for things that we're not thinking as machine learning. So in my opinion, and not because I'm a fanatic of Marvel movies. JavaScript is something like I'm sharing in this slide, and I'm going to this serum that is you're looking in this slide, because quoting this movie, we are talking about that in the correct hands. If it's a good person, for example, I'm quoting the movie, it's 10 times better than if it's in a bad hands. So JavaScript is so permissible and evolve and gaining areas. Do this in a very well hands developer that is taking care of good practices and code. There's a lot of potential. So that's what, and again, because it's permissible. And in the same time, in the wrong hands, it can create a code that we'll not be proud of. But this is JavaScript in a nutshell. And this skill or this ability is there. So this is the topic today, machine learning and JavaScript, that a few years ago we didn't see it like that. So machine learning and JavaScript. Before starting with this area, I would like to talk just machine learning, what we think it is, what we feel it is. And this depends of the context and the perspective of each person. If we think that this is not part of us, or we can think that or be afraid of the use or the potential of machine learning. But if we think what it is maybe something complicated or revolutionary the world. So two of those things can be true. So how a non-technical people think it is, this machine learning? We talk about this fight, good versus evil, dominating the world through computers. And I repeat, we can say, or we can see like a drastic scenario, but no, it's not as afraid of this. And it's because we are not understanding the topic or aspects of the topic. So personally, I think that yes, there are some destruction of the world that comes from the intelligence, artificial intelligence, but it's not like this slide. It's more like the human behavior and modifying the way the human thinks. And to think that maybe we are getting ideas through the AI, it's not so different as the social media. So machine learning is not a futuristic topic. It's right now with us. So let's see what we can do as the first steps with machine learning and JavaScript. A parenthesis, I understand that as an audience is not only from Mexico, Argentina, Peru, Colombia, but if I use a word that is different from your Spanish, I apologize in advance. So machine learning is not so different what we are seeing in this screen. We are teaching the computing as when we were in the elementary school. We have a data enter, what is this? And we tell the machine what it is. So the difference between what it looks like and what it feels is huge. My objective or goal in this talk is you can feel as simple as this. The processes, the knowledge process as easy as this slide. So let's think our learning process. This process is very simple. We ask a question and we think in possible solution or scenarios. So what we do is filter or define that set of words. Filter what is interest of us and those patterns, and then we start to iterate to know if our theory is correct or not according to the new enter. So Finally, when we say I learn, it's because I can decide what is correct and what is not correct. That is a learning process, and again, is the same as a computer. So let's do a small exercise. I will guide you to validate that this machine learning process is just the same as the human learning process. So we can understand a new topic, a new programming learning, a new language, etc. So this is not different of my process. So what is the computer doing? It's the same. We ask the question and we will try to answer the question and possible solution, list of possible outcomes or solution, filter that list, identify patterns from those. We are going to iterate to identify more patterns among the solution. So to identify that patterns, we are going to repeat that output as a new input until we arrive to a final solution. Eventually, we consider that we learned. And if we present this in a visual form, we have a raw set of data without processing, and then we filter what we are interested in. For example, history, perfect. Let's focus in a location or a year or a couple of years. So those will be the structures data that they are not raw data. They are not event. Now is filter set data according to our interest. Then we analyze. And with that, we have this new candidate model. So with the things I know right now, and if they ask me, they say I will answer like that. So that's why it's a candidate model. I need more data, and that's why my answer will change as more input I'll have. So this is a cycle process, iterative process, and each input or output or a process will become to our new cycle. So eventually, with the number of correct iteration, we will have like a golden model or the final model. So we are now okay with this model. And then we're going to connect our apps to this model. We are saying the app, if I have this input of data, eventually this will be the output, and I will be okay with that output. This is the process how the computer will learn, and it's the same as the human process learning. So at the end, the apps will connect to this model. So let's do it with this exercise. Let's start learning as in the same way as the computer. So this is the exercise. We have this word of set. We are going to learn how to pronounce some words in English. So we're going to filter, for example, letter O. Remembering this slide, we are processing the raw data to what we are interested in. So I'm not focusing in the English words, but just words that start with the O. That's my filter data set. That's my interest area. Each iteration or each new word will create an iteration and a cycle. So I will define a cycle. So I will listen, for example, a pronunciation with O, and I say, okay, O is pronounced in English like an O and U combined, so it's like O, and that's my model. It's not a final model. I just have one word, but my candidate model in the first iteration is like that. Then we will have a second word. For example, O plus H is similar like O. It's like the first one. This means that the same model applies, is correct. The one that I used to have in the other iteration can apply to this one. So I understand letter O is a combination of OU. However, we have the third iteration. So O plus N is no O plus U, is on. It's more like an A. So my new model will say, well, O plus N is between O and A, but anything else will be O and U, because in this three iteration is what I know. I don't care about the rest of the word. Until now, I just have three examples. So if a fourth word arrives, I will try to resolve or pronounce it according with the first three examples. Eventually, I will learn that operation is not like on, no, o, nor o. So I have a new model, and with this model, I will learn. So at the end, more and more words, I will have o, on, operation, observe, and I will have new data. With each new iteration, the last output will be the new cycle input. So my learning process is as simple as that. With this new word, I see the pronunciation, I compare with what I know, and I add it with my list word catalog. So I'm learning with each example. So at the end, I will have this golden model. And once I'm okay with the rules, and with this, I'm also comfortable with my output. So right now, my apps can use this golden model. With the sixth word of the seventh of the eighth word, I will say, yes, it's a O with a T or other rules that I'm learning in the process. I can predict that this word will be pronounced like that. So this is the learning process. And I'm sure that is the learning process that all of us have when we want to learn anything, a language or another thing. And let's see, models help us to predict. This means that they have a percentage of error or a mistake. So what they do is with all this data, I think that my output or my exit is like this. Let's think as a user or as a, like Facebook or Twitter or Google can give us different answers or suggestions. For example, friend suggestion according where we are or our last searches or what we did yesterday, maybe what we ate last night. So with this, or we can predict what can be important for us in certain day. And artificial intelligence is not an stranger of what we are doing. And why is the world changing? Because there are ways of thinking that, well, trying to tell us that are our own thoughts, but it's not like that. It's because they predict very effectively according to our searches, our friends that we are reading their posts and other decisions. So how this works, I think that even the creator of this model doesn't know. But the point here is what a model does is to predict very accurately or as accurately as it can the solution of the question. Some weeks ago, I think many of you saw this presentation, and I want to highlight about this presentation is when share or explain this chip implanted in different animals. I think 3 or 4 pigs that they implanted those chips. So The simple process to implant a chip in the brain of a human or a living being and to extract it without harming this living being is a success. And to extract information due to these nervous terminals is huge. Let's imagine implant ideas or thoughts. This inception term can apply, and maybe we are heading towards this, but for me right now, it's amazing just to read data, for example, to read those thoughts of a living being. So as you can see in this slide, this chart represent is through the nervous terminals, they can predict the movement of the pig, maybe to where the leg of the pig will be in the land to predict that use. And this was in real time. And the reading and the prediction that that leg will be. Each articulation will be functions. So what you see is a prediction versus what happened in reality. Again, just forget the reading or other things. Just think in the apps. For example, somebody that has an accident and can't walk can think about the movements. So why don't connect to just go beyond that part that prevent that person to walk and eventually can move with these terminals, nervous terminals, to do a bypass. So we can predict in a satisfactory way how the leg can be moved. So these implementations, just this implementation to read the data, not to incept things, just apps to predict something like this presentation, for me, it's amazing enough to want to know the next step in this technology. This was something that caught my attention, and it's just to highlight just two predictions. A model does not warranty the output of data, just predicts the output according to the input. Now, to arrive to implementation, there's a lot of libraries in JavaScript. So let's focus on this topic. There's one that we are TensorFlow JS, and TensorFlow JS is not the same. One is based on the other, and TensorFlow JS is this library for JavaScript that allowed us to learn models and to train models and to arrive to that golden models through JavaScript. So the advantage of TensorFlow JS, we can do a lot of from the browser and a server. They have a catalog of existing models, very extensive models. So we can just use it, import it, and start working with them and teach this model. So we do not have to develop our own models. If you remember, at the beginning was different, but we can play with this library. If these models are already existent, we can use it. And at the end, this library allows or determines a percentage of coincidence. So this is TensorFlow.js. And what we learning, or we start at the beginning of this talk, is this topic or concept of machine learning without being an expert in this. So this is what is interesting of JavaScript, how far arrived and how we can implement in some areas that some years ago we just said, no, that's not possible. So this example of the chip implanted in animals is just one example of that for me is not as realistic according to my abilities, but is there. So let's play a little bit more simple through with TensorFlow GS. So what TensorFlow GS is to prepare the raw data. Again, I will highlight this learning process. So we define or we create a candidate. Again, the pronunciation of the words that start with O. Maybe we just have like one or two correct words, but with time we will have more and more words. So what we are doing is to train our candidate model. So with more words, the model will be more precise and eventually will cover the majority of the scenarios. There will be some data different. They will not cover all the cases. That's not the goal, but just to apply a model in the majority of the cases and then validate the model. So that's the percentage of the loss that a model can have. And then we will make our own prediction with these same models. Again, an input of data, we run the model, and then we will have an output and with a percentage of precision. Another small backup to explain TensorFlow, the origin of this library. Tensor is mathematic terms, and I said at the beginning, I can't explain this. I'm not a mathematician, but in a practical example, with my level of knowledge, think about a boat in the ocean, and tensor represents the water flow against the movement of the boat. So when there's like a crash, it's not in an opposite sense. So it's like a hedge that push the water so the boat can continue flowing. So that conversion, the sense of the water and the sense or the direction of the boat in the different direction is a tensor. And a tensor in a data structure is that value and then converted in or transform it in a different output. And then you can scale that number or maybe in an array or a matrix. That matrix is tensor and start with, and that's why it's the name of the library. I can't explain the term, but I can give you an example. That matrix, that structure that allowed me in an input to transform it and have a different output. And with this, to have a prediction, which is a percentage of certainty of that output. With this, having this in mind, we can have some exercise. So let's play this library. You can have it with you through a CDN with a reference of a library online. So what we are going to do is work in a couple of examples. So with this slide, you will see a playground. And with this, it shows like the graphic of the learning process with the input data. And eventually what we are looking for is the output and the middle layer that will process or transform those data. So example, if my input data is horizontal and vertical, what I the prediction will be like in the center, like a circle, this blue data, and the exterior is yellow data or orange. And this will change according to the input. If this data input is not in the same directions, it's just a linear, the model will separate in this way. There are two categories. So half is blue points or dots, and the other half are orange dots. And this is important because represents or according to the data input and the neurons that we have is the predictions. With this platform, we can play and will change according to what we want to achieve. And there will be some dots outside these models, but it doesn't matter. It's just lost data, but the percentage continue to be higher enough. So library will create predictions. Again, a percentage. 100% is because it's 100% sure of the result. This is just a playground. What I'm interested in is know more about this library. And with TensorFlow, we have more than one example to train existing models. For example, in this case, we can learn the machine to know the difference between an automobile and a plane. So through a camera, it's like this. Define two models and to teach the computer that this is a vehicle, a car, and the other is a plane. And at the end, according one to the other is as the computer, you will decide if it's a car or a plane. Maybe this is a very simple example comparing to predict how the animal will walk. But we need to start with something. So this is the data input, and then we will start with a circle. Receive the data, learn with every image. We are teaching the computer to differentiate one object from the other. And once it's ready, or once process all the images, or I read all the words that start with O, then the model is ready. When I, for example, in the second example, will know when I show another picture, if this is 100%, this is a car, or if 100% a plane, and to change one with the other. So the library will define the percentage of certainty that our model has that is just learned thanks to the images. So this iteration process, explained before, continues capturing data and says, this is a car, this is a plane. And with this, there are different applications. For example, you can download in your mobile just to know if the picture is a hot dog or not. Or with an images, you will know if that thing is, you can hug if it's a dog or a cat. And of course, there will be some difference according to the inputs. For example, an image to know if it's a cat or a dog. And while it's learning, I show an image of a Terranova. Maybe it says it's a bear, not a dog. But with more and more images, the machine will learn. Like this example. So I invite you to play Pac-Man with the YMCA or images, as we just did, where you say, well, where is upstairs, downstairs, right and left. So you will run a lot of libraries, and you need to understand the main concepts, which are the process, because we know the learning process. We know that we have the library TensorFlow GS, so we can create our own app and use existing models. We can train this model, and eventually we can say that dog is that kind of brand. So you can take a picture of a puppy, and we'll look in the different social media if somebody report that puppy as missed with similar characteristics, and eventually say, well, there is. Yes, so from my part, we are okay with time. So I'm finished my talk, and right now, just ask yourself a couple, well, a question and a challenge. So let's start playing with this library. This was a very simple demo. So took this demo to the next step. This will be like first one. And the second one is to answer this question. So how machine learning help your business or on a daily basis? So why use it in our business? Well, knowing these other concepts and knowing the library that will allow to reach different levels, why not JavaScript? So this is a question that I put on the table. So if you have any question, I'm here. I hope that this is an interesting topic. Of course, we are not going to be experts, but just to have like the first step of machine learning and JavaScript. So thank you.